In this experiment, the performance characteristics of Pelton Wheel hydraulic turbine will be determined. The Pelton Wheel hydraulic turbine is driven with a jet of water from a nozzle. It strikes with the buckets on the wheel. The water jet causes the wheel to rotate, producing torque and power. The water is supplied by a pump from some tank inside a hydraulic bench. The Pelton wheel operators consist of spare valve. The flow rate of water jet is controlled by a spare valve. Pressure gauge located near the spare valve and can be used to determine the head available to the fluid. Pelton wheel, at the periphery of which buckets are mounted. The Pelton wheel is provided with a casing, and the function of which is to prevent the splashing of water. A brake system is used to measure the torque on the shaft. This system includes two spring balances connected by a rod that wraps around the shaft. Before starting the experiment, make sure both the valves are closed, spare valves and the flow control valves on the hydraulic bench. Then ensure there is no tension in the cord connected the spring balance. Adjust the screw at the top of the spring balance until the cord hangs loosely from the hooks. Sets if there is any zero error. After water leaves the turbine, it starts to accumulate into the side channel of hydraulic bench, where volumetric flow rate can be measured using side tube. Turn on the pump in the hydraulic bench, then fully open the flow control valve of hydraulic bench and gradually open the spare valve of Pelton wheel until it is fully open. Produced water jet will strike the buckets and run the Pelton wheel. Record the pressure reading using pressure gauge. Increase the load on the shaft by increasing tension on the spring balance. Now adjust the screw above both spring balance to reduce rotational speed of Pelton wheel. Using tachometer, measure the rotational speed of Pelton wheel. If tachometer reading will vary slightly in time, so estimate the average. Record both forces indicated on the spring balance and repeat the process with reduction in rotational speed by adjusting the screw on the spring balance. The volumetric flow rate is determined by closing the dump valve and observing the water level on the side tube of hydraulic bench. Start the stopwatch when the water level reaches 0 liter and stop it when it reaches 20 liters. For second set of reading, reduce the flow rate by closing the spare valve completely and then reopen it only 2 turns. Now repeat the process for this rotational speed and record all readings including force, pressure, torque and flow rate. Using these formulas, student can perform specimen calculations as flow rate can determined by using volume and time. Head available to the fluid at inlet of turbine is static head. Torque can be obtained by the multiplication of tachometer reading with radius. Fluid power, brake power, overall efficiency can be determined using these formulas. After completing this table, student can draw performance characteristics of Pelton wheel at constant head between speed versus discharge, speed versus overall efficiency, and speed versus power.